Alright, good morning grade 11s. Today we are talking about rational exponents. Now rational exponents are literally exponents that are fractions. Apologies. So exponents that are fractions. So last year I did introduce this very quickly. Basically, if you have an exponent that is a fraction, you can rewrite that whole power with that fractional exponent as a surd. So from last year, you might remember this, you might not, but we said that if you have the nth root of a to the power of m, that you can rewrite that as a to the power of m over or divided by n. Now guys, we we did this in grade 8 even, or you would have done this in grade 8 if you were given something like the fourth root of x to the power of 16, y to the power of 4. Then you would say, okay, what do I do when I have to take this fourth root? Well, what I do is I take my 16 and I'm going to divide it by the 4. And when I do the fourth root of y to the 4, I'm going to take the 4, which is on the inside of the surd, and I'm going to divide it by the 4, which is on the outside. Now this step you wouldn't usually write down, you would just kind of do that in your head, but I'm just showing you guys that you have actually worked with this rule before. So now, obviously this year we're going to be applying it in a more kind of complicated way than this example that we've just looked at. Sometimes they will ask you to, let me actually just write here, examples. Sometimes they will ask you to simplify numbers without the use of a calculator, and then you have to show all your working. So if they are asking you to do something like to write the fourth root of 125 in simplified exponential form, all right, so the fourth root of 125. Now, since they want us to write it in exponential form, we'll talk about the simplified part just now. It would be good for us to actually do that now. Now, on the inside of this fraction, or not the fraction, sorry, on the inside of the surd, 125 has an exponent of 1. It's just not written there. So to write this in exponential form, we're going to say we're going to have 125 to the power of, now let's look at this example, or this rule rather, here at the top. The number that, or the exponent inside the surd becomes the numerator of your answer, and then the number or the numerator of the fractional exponent in your answer. Sorry, I'm going to say that again. The exponent on the inside of the surd, so m in this case, becomes the numerator of the rational exponent. And then the number on the outside of your surd, so n in this case, becomes the denominator in the rational exponent of your answer. Okay, sorry about that. So here the exponent on the inside of the surd is 1, so we're going to put the 1 at the top of that fraction, and that is then going to be over 4. That is the number on the outside. Okay, now this is exponential form, but it's not simplified exponential form, because we can actually still, let me just see, did I actually copy this down correctly? Yes, I did. We can actually still change 125. 125 in itself, the number, is not written in like simplified form. We can actually write it like this, 5 cubed, right? And that will then be to the power of a quarter. And now we know that rule, if you have an exponent inside a bracket and outside a bracket, you would just multiply those two exponents together. Okay, now this example is not one that you can necessarily expect to be asked in a test or exam. I'm just showing you kind of how it works when you're going from surd form to exponential form. But don't worry about a question like this. You are more likely to get a question that you can actually simplify further. So if we're doing something like in number 2, simplify, let's see, the 6th root, no, let's do the Sorry, I'm looking at my examples here to find a nice one. Yeah, I suppose these examples... Okay, let me do this one, sorry. Simplify without the use of a calculator. If we have something like, this is now the question, I'm just going to write it over 2 lines, it is a fraction. 8 over 27 to the power of negative 4 over 3. Now, you can go to surd form with this if you want to, or you can keep working in exponential form. I sometimes just prefer keeping my working in exponential form. But what I want to do, obviously they've said without the use of a calculator. Now guys, I don't think any of us are capable to just say, okay, what is 8 to the power of 4 over 3? You know, maybe you can eventually figure out how to do that in your head. But there is a way of doing it by thinking how we can cancel out that denominator there, right? Because the fact that this is a fraction makes it difficult for us to get the actual value of this number without using a calculator. So we don't want this exponent to be a fraction. We want it just to be a whole number, because then we could work with a whole number, right? If we just had a power of 4, then we know what something to the power of 4 is without using a calculator. But 4 over 3 is not really workable. So what we want to do is we want to get rid of that denominator of 3. Now guys, remember, if you have an exponent inside a bracket and outside a bracket, right, like we have here, you times those exponents together. So if I want to get rid of that 3, which is in my denominator, the 3 at the bottom of the fraction, then I need to write both of my parts, right, my numerator and my denominator in this fraction, in the brackets, as a number to the power of 3. So what I'm going to do is, let me just get rid of all those little things there. What I'm going to do is I'm going to rewrite 8 as 2 to the power of 3. And I'm going to rewrite 27 as 3 to the power of 3. That is still to the power of negative 4 over 3. But now, in the next step, when we actually now multiply these exponents together, we're going to say 3 times negative 4 over 3. That is going to allow the 3's to cancel out. Then we're going to do the same thing at the bottom. We're going to say 3 times negative 4 over 3, and that again will allow the 3's to cancel out. So I'm going to be left with 2 to the power of negative 4 over 3 to the power of negative 4. Now guys, from here, again, the question says without the use of a calculator, we're not allowed to just type this in. So we have to show that, okay, since that has a negative exponent, I need to move the 3 up. And since the 2 has a negative exponent, I need to move the 2 down. And we're going to get that. And now hopefully you know what 3 to the power of 4 is. And I'm sure you know what 2 to the power of 4 is. So that is going to give us an answer of 81 over 16. If you're not sure, I mean, I'm not going to know if you do actually type 3 to the power of 4 into the calculator just to check. But you would have to show all the other steps, guys, to prove that you are not using a calculator for that. Okay, so example number 3, we're going to do one now with variables only instead of numerical bases. So we're going to have a to the power of 2 over 3 times the cube root of a to the power of 4. And that is over a to the power of 3 over 4 times the 4th root of a. Alright, now guys, we are familiar with the law of exponents that we've been using for years and years now already. That if you have the same bases, you're going to add the exponents. Now here we do have the same bases, right? But this second part, the second expression that I have here is not written in exponential form. So in order for us to be able to apply this law, we are first going to have to write that in exponential form. The same thing happens at the bottom of this fraction. We again have two bases of a, but again the surd there is written in surd form, obviously not in exponential form. So our first step is going to be to rewrite both of those surds in exponential form, and they are going to have rational exponents. The exponents are going to be fractions. So we're going to have a to the power of 2 over 3 times a to the power of 4 over 3. Remember, number on the inside goes at the top, number on the outside goes at the bottom. Over a to the power of 3 over 4 times a to the power of, now in my denominator, the a inside that surd has an exponent of 1, it's just not written, and then that's going to go over 4. Okay, next step, we are now actually going to add those exponents together. So we're going to have a to the power of, now guys, 2 over 3 plus 4 over 3 is 6 over 3, or you are more than welcome to write 2 straight away, that's perfectly fine. And at the bottom, we have a to the power of 3 over 4 plus 1 over 4, which is just 1, right? 3/4 plus 1/4 is 1. Okay, now we have a squared over a, which is equal to a final answer of a. Okay, let me see if I can find another nice example here. All right, let's do a show that question. Yes, sorry, I'm just looking at my spacing. All right, so number 4. Show that. So this is now like an identity kind of that we have to prove. They are giving us something on the one side, and on the other side we have to prove that that is true. So we have the cube root of ax in brackets. Sorry, I just want to make sure I'm copying this down correctly. And then that whole bracket is being squared, but there's an x in the numerator there. And that is equal to the cube root of ax over a. Now guys, in this type of question, actually I just want to move, I'm going to move this a little bit further down there to where I have a bit more space. And I also don't want to have to zoom in that much. All right. When you have a show that question, and guys, this is something that is going to come up so often from basically grade 11 going on. A show that question, you may not work on both sides of the equation at the same time. Guys, they didn't ask you to prove or to solve for x, right? If they had asked you to solve for x, then you would move things across the equal sign, perform reverse or inverse operations until you get an x on its own, and then whatever is on the right hand side is the answer. But now they're saying we must show that this equation is true. So you may not work on both sides simultaneously at the same time. That's very important, guys. What we're going to do is we are going to choose to work with the left-hand side. And you are allowed to write LHS, exactly like that. Even in your final exams, they accept that as like an abbreviation. So we're going to say left-hand side. What did we start with on the left here? We started with the cube root of ax squared at the bottom in our denominator, and we have x over that. Now guys, we need to change what we have here on the left-hand side to what they gave us on the right. We basically need to do things step by step in order to prove that the left-hand side, which is what we're starting with, is equal to the right-hand side. So basically we are going to try and change this expression to the circled expression on the right. Now the first thing that I'm noticing here is that at the top of the left-hand side we have an x, At the top of the right hand side there is no x. So at some point we're going to have to cancel this top x out with an x at the bottom. So somehow we're going to have to end up with an x at the bottom, right? So I'm just going to write on the side here things that I'm noticing, things that we're going to have to do. So we're going to have to cancel out the x. Now at the moment what we have here, we are not able to cancel out that x, because if we look at the denominator, we are kind of stuck with that third. We have a cube root of ax, and then that is to the power of 2. Now guys, if we had a cube root of ax to the power of 3, then we would be able to say that the cube root and the cube will cancel each other out, which will leave us with an ax at the bottom. All right, so that's something to think about. Now let's again take a look at what is on the right, the circled expression that we are having to prove. At the top of that fraction, we have a cube root of ax. On the left-hand side, the one that we are starting with, we don't have that, right? We just have an x. So we are going to somehow have to introduce a cube root of ax at the top. All right, so I'm going to write here, introduce cube root of ax in the numerator. Okay, so those are the two things that we're going to have to create, the things that we're going to have to do in order to prove this identity. We call this an identity when they say show that one side is equal to the other side. Now guys, hopefully you've picked up that there is a way to do both of these things in one, or using one method, right? If we multiply the top and the bottom, remember we are allowed to multiply the top and the bottom by the same thing, because then that means that we are actually multiplying by 1. So what can I multiply the top and the bottom by in order to allow me to introduce this in the numerator and be able to cancel out x in the denominator? Or sorry, be able to cancel out x in the numerator by having an x in the denominator. Well, if we multiply the top and the bottom by the cube root of ax, let's see what happens. Cube root of ax and cube root of ax, I am going to get x times the cube root of ax over the cube root of ax, sorry, let me straighten that, cubed, because it was squared. Now I'm multiplying it by another one, so that then gives me the cube root of ax cubed. Now look what happens, guys. Now the cube root and the cube are going to cancel each other out, so I'm going to have an x times the cube root of ax at the top, and at the bottom I am going to have an ax. Perfect. Now I'm able to cancel out that x, and I am left with only the cube root of ax all over a. Now guys, in this question we didn't actually have to use exponential form. We could continue working with surd form. So the rational exponent section is a bit difficult to summarize in one note because there are so many different types of questions that you can get. If we look at the first one was just a very basic kind of converting from surd form to exponential form and then just simplifying it so that you have a prime base essentially. That is what we ended up with at the end. We had a, oh, that's a funny looking eye. We had a prime base at the end. For number 2, we worked in exponential form. We had an exponent that was a fraction. In order to change that rational exponent, that fraction exponent, to a whole number, we had to raise the numerator and the denominator to the power of 3 so that it would cancel out that denominator of 3. For the third example, we had to convert two expressions that were written in surd form to exponential form so that we could simplify from there. And in number 4, this is more like kind of an algebraic manipulation type question. We didn't have to convert to fraction or to exponential form, sorry, but we had to recognize that we are going to have to multiply the top and the bottom by the cube root of ax in order to get to the right hand side. And sorry guys, that's actually something that I left out here for these questions. Once you have actually gotten to that other expression, you have to say in your final answer equals RHS. So you start by saying left hand side is equal to this. You then work on the left hand side only, not on the right. It's almost like the right is the answer that you're trying to get to. So you work on the left hand side, change the left hand side. Sometimes you might have to factorize, sometimes you might have to apply exponential laws and so on until you get to what was given on the right hand side. My apologies. And then you say equals RHS. Okay, I just want to see here, that was actually the last example in the textbook. All right, you guys can start working on the tut now. Let's quickly see, do I have the tut here? No, that's not it. I don't actually have the tut here, and I also don't have a textbook, so I can't look to see which questions you can do. If you, maybe just take a look. It will be under the rational exponents heading, but we are meant to be doing some equations and stuff. We will do those on Friday. All right, thank you, grade 11s. I hope that you have a lovely day. I will see you guys tomorrow.